thanks for having me out here. This is sludge blanket level. If you're in a different class, too late, the door's already shut. So good luck. Kidding. So I'm Joel. I'm with Pulsar Measurement. I've been there on and off for about 6-8 years now. Kind of got started after I left the military, got into flow and level instrumentation, and really kind of took a shining to sludge blanket level. And I've worked in quite a few different projects, mostly working on continuous sludge blanket level, but really seeing a bunch of different stuffs from North, South America, a little bit in Europe and so on. So different regional varieties on how people use sludge, but it's all the same thing, right? So we're going to talk a little bit about the kind of scope today. But before we get to that, I always want to try to take a safety moment. So fire exits, it's pretty easy. Down the hall to the right is the front door. If that exit is blocked, just down the hall, take a left and take another left. It's a secondary exit there.
What about that one?
Oh, there's a fire door right there too. That one's blocked. There you go. Yeah, y'all looking out for me already.
Yeah, you failed the test. Okay.
To be fair, there wasn't a posted plan, so technically they failed the test. So I always like to talk about just like as part of the continuation of the safety moment. You know, I'll say who here doesn't have tinnitus, because if I ask who does have tinnitus, no one would raise their hand because we all got it in some form or fashion, right? We're around heavy equipment, we're around large items. So something to be important, your hearing pretty much isn't renewable, right? Especially those of you in the military know this stuff is not renewable. You've got to look out for yourself, protect yourself, right? So take a little bit of time, invest in yourself, right? Anything over 100 decibels, you can see, depending on the amount of exposure, you're going to have an issue, right? So October is the month where they like to try to remind folks of that. It's important to make sure that you're able to continue to do your job as long as possible. I know a lot of times we go, it's not a big deal, but Ear Pro is nice to have, right? Especially if you get one that has a rating on it, listen to the ball game. So just to give you an idea, for those of you who shoot, that's about 140 decibels, right? So that's something to keep an eye on if you're around, even something a smaller engine like a motorcycle or running a driver. That amount of exposure can actually build up over time, right? And can hurt you quite a bit. So we think, around this all the time, not a big deal. Also, what was that you said? Because I'll probably, if someone ends up having a question in the back, I'll probably be doing that same thing. So I'm preaching to my little dumb self here. So we talked a little bit about me. I wanted to kind of get an idea of y'all, what y'all are looking for. So this is an operator class, wastewater class. I want to see in Idaho, it's levels, right? So it's level 1, level 2, level 3, correct?
Yeah.
So let me see, show of hands, who's my ones? Ones, okay, 2s? Cool, 3s? Gotcha. Any 4s? All right. Gotcha. So most of y'all are 4s. Yeah. Okay, cool. That's good to know. What about plant capacity? So let me see 1 MGD and less. See hands. Okay. 2. I'd say like 5 MGD and more. Okay. Anybody above 5 MGD?
Not here.
Not here.
Great for 6.
Great for 6 perfect capacity. Okay, gotcha. Anybody beat 6?
15 years ago,
Gotcha.
I started with 32.
Nice. Big boy.
Six secondary clarifiers for revision.
Oh yeah, I believe it. That's a lot of fluff. I hail from Tampa, Florida. And, there's just an explosion in population, plus a lot of groundwater, plus a lot of rain. We have to design really high permit capacity. So the big plant there is 120 MGD. That's just one of 8 that handles the Tampa metro area. I think it's something like over 250 combined across all the different plants, just on the wastewater, not even the water side. So pretty extreme. Cool. Now that's helpful for me because I want to make sure that I'm not talking, hey, you're secondary clarifier. Y'all, if that's not relevant. All right, so especially going to be looking at my floors and everything else. I'm going to ask y'all some dumb questions, and y'all get to teach me today. All right, we like this idea? So why do we measure sludge? Why do we go out there and take a measure, other than the boss says we have to? Nice open-ended question, right? So this is what we're going to be talking about today. Why do we measure sludge and types of technologies, especially looking to the future, as we try to do more with less? We try to be more efficient. We try to be more conservative of the chemicals we're using. We try to be more careful of the manpower that's, unfortunately dwindling away. We try to look at that. So we're going to be looking at a couple different categories. We're going to be looking at manual measurement and then automatic measurement, some of the more modern options that are coming into the market. We're going to be looking at optimization and future proofing as well. So not just the how, but the why we're looking to it even to the future. All right, so a couple different examples of different categories. So primary clarifiers, you could have round or rectangular types. I'm imagining, y'all educate me because this is my first time in Idaho. Are most of yours open or are they covered? Open, pretty much all open. Yeah. I pretty rarely see covered tanks anymore unless there's like, it's in the middle of the city and people are complaining about odors and that type of thing. A lot of times you're going to be running denser sludge because it's the first in the process, as we all know. So you're going to be running 3-5% solids is really common. Outgassing is being more prevalent, and your blanket can be affected by flow rate. Are most of yours rectangular or circular clarifiers on average? They're probably circular. That's what I see more commonly. Yeah. Okay. So secondaries, similar process, but now we've kind of already gone through. So we're going to be looking at lower density sludge, typically even down to 0.5% solids, with some outgassing being prevalent, but not that much. Does anybody run any thickeners? There's some thickeners. Okay, cool. My thickener guys. It's usually smaller tanks. You're going to be building up a really thick blanket as compared to the others. And it's typically a bit more of a challenging measurement. What levels do y'all typically run in your thickeners as far as like a desired set point?
5%.
5%, yep, pretty common. And we've all seen clarifiers before, right? So pretty typical design, center section, skimmer, where the influence is going to be coming up through, and then it's going to be settled through, and then you're going to have a sump taking away the withdrawal. Similar design on the rectangles. So the whole point of a clarifier is that we're trying to remove as many solids and associated pathogens as possible from the wastewater. We're trying to remove the waste from the wastewater so we can treat the waste and return the water back to the local waterways. So our design goal, our expected ability is we should expect to be able to remove in primary clarification. We should be able to 95 to 99% solids. Right? That should be kind of the expected time. We should also expect to only be using our clarifiers for 2 to 3 hours tops. Anything less than 2, now all of a sudden we're not getting enough time for those solids to settle out. Anything longer, and then that's sitting too long. We have running the risk of becoming septic. Right? I know there's a tendency to use clarifiers as a storage tank sometimes. That's certainly something we want to try to stay away from. All right, so our goal detention time is 2 to 3 hours. Who can tell me what weir overflow rate means? So along the top edge of the clarifier, especially the round ones, you're going to have those little weirs. A lot of times they're V-notch shaped. It looks like it was cut with a sawtooth blade. And so the idea is that per linear foot of weir, you want to be having 10 to 20,000 gallons overflow. So we don't want to be running too much because we run the risk of solids spilling over. And then we want to make sure that our loading rate is 300, 1200 GPM. So we're going to get kind of into the meat and taters of the technologies. So we're going to go over some manual sampling and some automatic sampling. Some of this is going to be kind of exotic stuff that I don't even see in larger design plants, but it's still great to be able to be exposed to it, right? Have any of y'all worked in industrial, either pre-treatment or wastewater before? Or is it mostly on the municipal side? I'm not sure if that's prevalent for y'all. Where I'm from, there's a lot of mining. So there's a lot of risk with super acidic groundwater going into the soils. So we're required to do industrial pre-treatment to make sure that everything else. Give you an idea of how nasty the water is. Operators go through about 6 pair of boots a quarter because it's just that acidic. That's just the groundwater sitting on the ground. Right? So I'm like, why is the Red Wing truck always here? It's like, well, this is why, brother, because we go through a lot of boots. A lot of boots. All righty. Technically, we're not supposed to talk about brand names in this type of presentation, but it's ubiquitous, right? Who here does not know Sludge Judge? You know, it's pretty common. But I want to do a little bit of a pop quiz, all right? Can someone give me the book definition of how you're supposed to take a measurement with a sludge judge? I see some smiles. I see some smiles. Folks willing to.
Obviously not from Idaho, we don't know how to read, so. All failed that test.
That's okay. They accounted for you guys and they gave very specific instructions on hand over hand and so on. So
YouTube.
YouTube. Hey, Chat GPT, how do I take a sludge blanket measurement? Right. So it's a clear plastic tube with a valve on the end. You insert it into the clarifier. Once it presses on the bottom, it pops open that valve, and it's just like if you were to take a straw into your glass. You cap it, and you can pull it up, and you can say, hey, there's about 2 inches of Coke left in my glass. Well, now you can see I've got this amount of water, this amount of solids, right? So an important thing that often gets forgotten is that you're supposed to take this measurement at the same time of day, at the same location. And, you know, if you've got a catwalk, ideally, you want to be about 1/3 to 2/3 of the radius from the center. It doesn't matter so much where as it matters the consistency. So the idea is you're trying to take the same snapshot you control for all the variables. You want to have the rake arm be furthest away from the sampling point, and then you want to slowly insert that sludge judge hand over hand, right? So you don't have to go too slow, but about a foot per second is what the book definition is. And you also want to be completely perpendicular. So that rod needs to be going straight down. We don't want to be casting it or bending it as much as possible. I know that can certainly be challenging. And then we want to take a look at the solids, the light and heavy. So if we don't follow that procedure, what happens? Got a nice little video that demonstrates this. See if we can, hopefully this works. If not, we'll have to. Sounds like the sound's not going to come. That's okay. We can live with that. So what this guy's doing is he's taking a measurement, and you can see, and this is kind of the right speed, right? So we definitely all wear gloves when we do this, and we use the right PPE and all that good stuff. 'Cause it's pretty nasty. And this is about the speed you should be looking for. Hand over hand, slowly inserted, slowly dropping down to take a measurement. And he's waiting to feel the bottom. You see the flex in the rod. He's capping it, pulling it back up. So you can see right here is his sludge. You see a little bit of stuff that's still settling out. And then what he's going to do is he's going to take a couple more samples, but he's going to do them either too fast or too slow. And we're going to see how that can dramatically affect the measurement. This is super critical, because we want to be as consistent as possible, even down to the location we're measuring, the time of day, etc. So you see how much faster he's kind of slinging it in there, right? That was probably 3, 4, 5 seconds, tops. And you see how that sludge has quadrupled. It's absolutely quadrupled. We had, I'll pause and tell a little apocryphal story here. Uh-oh, broke it. I broke it. We were at a plant and they were like, hey, your unit, it sucks. It's not giving me a good measurement. Everything else. I'm like, okay, well, what should the blanket be? Well, we stuck it the other day. Reading was, I'm going to say like 3 feet, right? Okay. well, how come on your charts you see like 3 feet here, 7 feet here, 3 feet here, 6 feet here? So they had 8 guys on shift. It was a pretty big staff. And what they did is they kind of tried a blind test. They said, okay, guy number 1, you come out. Everybody else, stay in the air conditioning. You come out, took a measurement, wrote it down. Next guy, measurement, write it down. Next guy, measurement, write it down. Next guy, measurement, write it down, and so on and so forth. Every single one was with a huge, like 3-foot swing. Just absolutely different because of how they were doing it. Some are too fast, some are too slow. And it was pretty much only the actual manager who's reading right on there. It should have been. All right, so he's going to take one really quick. And he's letting it sit in there for a good long time. Now all of a sudden we have an absolutely huge, that's like a 4-foot level. So we're bouncing plus or minus 3 feet here from the intended set point. So how can we have a good consistent number and understand where our sludge level is? So once again, best way to be doing this, hand over hand, slowly insert it about 1 foot per second. Take your time with it because it's pretty important to measure your sludge to make sure you've got good health in your clarifier.
I see you need crystal.
Right.
If you've ever seen one go right into the third,
Yeah.
Yep.
how is that risky?
Yep. I think he's got one, but he's not using it. He's just keeping it in his hands. So that's a great observation. He should definitely have that because I've certainly dropped things. Even if your cell phone's IP rated, I don't know if I would want that kind of IP back in my pocket.
Lost a lot, so.
Yeah. There's a reason I only use cheap ones now.
It'll come out the press.
Sorry, honey, I missed your call because, oops. Is that video pretty clear? Pretty helpful to understand the difference? All right. So also wanted to touch on accelerometer test, IMHOF testing. Yep. Settle test. Everybody should be pretty familiar with this. So what we're doing is, this is not a direct sludge measurement, but it's really critical nonetheless to understand the health of our clarifier, right? So we take a grab sample, we chill it, ice it, and make a test at room temperature. So you allow it to sit for a while, hopefully get to room temperature. And here's one that I see missed often. So for on your test, reports are reported in milliliters per liter. This is a volume measurement. So ideally what we'll see is a nice separation where your sludge settles to the bottom, and you have your clear supernate and your cleaner water that's going to be going over the top. If you don't see that, then that means you got a problem in your process. You're going to be upset, and your clarifier is burping or something like that. You need to take a look. Okay. Another point level device. Has anybody seen an optical style tape sensor? Anybody use something like that? Mr. Casey has? Okay. So these are very similar to a sludge judge, but the idea is that you want to take the manual variance out of it, depending on how fast you inserted it, take it back out. Essentially what this is, it's a probe on the end of a spool rod, and as you let it out, it takes a measurement of the density of the solids. So it's designed to remove that ambiguity, that uncertainty of, oh man, was like 3 feet, was like 2.5, was depending on how the operator is inserting it. But the downside is you still have to be out there in the weather. You still have to go out there on the railing, cold or hot or wet. There's a higher cost associated with actually purchasing the instrument, utilizing it, making sure it stays calibrated, and it's not automated. So it controls for a little bit of the requirement with a manual, but so it's kind of a half licked where you can get a little bit more accuracy, but it's not the full benefit of a manual operation, or excuse me, of a continuous operation. So let's slip into some continuous operation. So similar to the last one, but this one is fully automated. So there's some manufacturers who make an optical or infrared probe, and it's on a spool piece. The system will automatically come in here, say, hey, every so often it'll let that probe down into the blanket. And as time goes on, it'll take and stop at different points. So it'll hopefully, if you have a clear supernatant, take a measurement there, take a measurement at the settlement layer at the flock, and then at the actual blanket. And it can kind of give you a nice profiling automatically. And the way it works is the probe emits light, and then there's cracks to where it can basically say, depending on how that light is refracted, that's proportional to the density of the sludge. So it gives you a measurement, and so you can see the suspended solid concentrations. So basically drops that probe down and then pulls it back up. The downside of this type of measurement is it's still a contacting process. So it's very prone to fouling because you have these small gaps where the light needs to come through. So if you are interested in this type of this system, I highly recommend that you get something that's got like a spray nozzle on it or a purge. For you guys, since y'all get cold, have to worry about freezing and all that stuff too. But if you don't have a purge on it, it'll get fouled up and just be a maintenance nightmare. Definitely something to think about. But one thing that's really cool about them is some can also detect turbidity. This is not the same accurate measurement, but it can still give you a good idea of the overall health of the process. It's not going to replace your turbidity dedicated meters with a higher accuracy. They'll have a strong correlation to give you another data point to pull on the SCADA, but it's not going to be something that's going to replace your other meters. So there's this probe style. There's also, I'll call it like a light bar or a lightsaber style, where this is inserted all the way down the tank, and there's two different halves to it. And that's a teeny tiny gap, and that's what the light is continually reflected to. So rather than every so often it drops the probe in, this lives in the tank all the time, but it exasperates the maintenance hassle. So it's definitely something to think about if you're evaluating continuous measurement. Yeah. This is going to be something that you want to dedicate time to. On the higher end, there's some pretty exotic stuff out there. This is a radiometric design. So for really heavy industrial processes, occasionally if, especially if there's like a really high pH value, something like that, where you don't want to be in contact with the process, it's actually hazardous. Or if it's a finished process where you don't want to, say like food and beverage or something like that, where you don't actually want to have humans in contact with it to preserve the rating. What it does is there's a detector that emits basically nuclear radiation through the process. And based off the deflection, you have a emitter and something on the other side of the tank that can read it. So it'll look like almost like a rack of temperature probes or something like that on the side of the tank. And it'll read the density of the sludge based on how that signal is attenuated. Meaning it starts off with a really big signal, and then it gets smaller the more sludge it has to fire through. Right. So the advantage is it's completely non-intrusive. It doesn't go in the tank, and it can handle super duper dense sludge. A lot of times these industrial processes, it depends. Sometimes they're just taking raw water and trying to settle, clay and crap like that out of the roof before they use it in the process. But a lot of times for the industrial pre-treatment, that the actual sludge is incredibly dense, much higher than we deal with wastewater. But the downside is there's two big things. It's quadruple the cost, if not more, of other monitors that we would see in the wastewater world. And there's a huge regulatory burden because we're emitting nuclear radiation. Right? So it's another hassle where you're going to have health and safety involved. You're going to have engineers come out and spec it and check it, all that stuff. And that's something they deal with, on the daily. But thankfully, we don't have to for most of the time. Wastewater. All right. Who's seen ultrasonic sludge monitors before? Yep. Bigger plant guys. This is very similar. Who likes fishing? Yeah. So in Florida, we go offshore a lot, grouper fishing, et cetera. Pretty awesome. But a lot of times we're trying to hunt and find the fish in the right spots. So we use, fish finder, bass finder, et cetera. Same thing, just like on the lake. We just have to shoot it pretty far. And this is doing the exact same thing. It's using ultrasound, which is basically a sound wave going to the water. And it works just like a fish finder. It sends out that pulse. In the fish, it reflects off the air of the fish's gills, right? Instead, for us, what we're doing is we're actually reflecting that sound off of the sludge or off of the flock. So this is cool because the sensors, they tend to live up at the very top of the supernatant. So they don't tend to get as dirty depending on the process. And then depending on how defined your layers are, you can see supernatant, the flocks of the settling materials, and then the actual compacted sludge one. So some of the advantage of this one is it's pretty easy to install and retrofit because you just drop in a probe into the top of the tank, just like you see here. A lot of times you can mount it off the catwalk out to the center, and then you can detect multiple interfaces. One thing I will suggest is if you're looking at this style, make sure you've got one that's got a wiper that looks like a windshield wiper, goes back and forth. There are some styles that I've seen where the wiper is mounted in the very center of the probe. It goes in a circular fashion. And if you've got any silica or any ragging that happens in especially in primaries, the beard that builds up, actually I have a picture of it. Yeah, that builds up on the sensor can actually cause the gears to strip out, which causes the probes to not last near as long. So definitely look for something that only goes in a wiping motion rather than a fully circular motion. So nerds would call that I can't say that word, filamentous upset condition. You've got all that stringing and all the hair that will come off of it. So as far as maintenance with these sensors, every so often, every few months, you pull them out, you spray them off. But because they live underneath the water, you shouldn't see that much sludge build up on them. Another thing that's nice about them is that they don't tend to have much measurement drift. So you don't have to go take these out, rip them out, send them back to the manufacturer, be calibrated and so on, like some of the optical stuff. But you do have to be careful. If they have a wiper on the front, they can clean the face off, which is super important to get a good measurement. But you can see adhesion on the sides, especially with that silica. So here, some of the things, primaries, secondaries, thickeners. We've used them in a ton of different applications. It's just specs if anybody's interested. So some of the benefits is what I really wanted to talk about for continuous monitoring. You go, hey, Joel, this is great. We stick it with a sludge judge. It more or less works. Why would I bother looking at making a continuous process? And there's a couple different ways that you really want to think about it. First off is you get a continuous measurement. So the big takeaway for continuous over manual measurement is that you can get a 24/7, 365 view of what's going on in the tank, which is huge for seeing process conditions come down. I'll give you a real world example of this on the next slide. It actually happened a few weeks ago in Argentina, where they had a big storm event and they were able to kind of see it and react much faster. So that gives you the trending data. So you can not only see current conditions, but you can pull it into your plant story. You say, hey, cool, on this event, what happened to our clarifiers? How did we react? Or our set points set optimally and so on. You get a lot of cost savings because of the stability. Ideally, you're only dewatering, pulling your waste out when you actually need to. So you're not decanting water, which is going to cost you time and money and so on. Do y'all treat on-site for your waste, or do you tend to bus it out or ship it out?
Ship it out.
Mostly ship it, yeah. We have in Florida, there's a couple places where they have like third-party companies who are on-site who will actually treat it there for free, which is kind of crazy. A lot of it's just centrifuges or bell presses to dewater it. And it's a huge, probably like after blowers and chemical is probably the third cost center for their plants on average. And the nice thing about this is, I mean, when you're using polymers and so on. I was in a meeting from a bunch of eggheads at different engineering companies, and they were talking about trying to find ways to optimize chemical usage in plants. So what we've been seeing a lot in Florida specifically is chemical plants shutting down and rail being harder and harder to get product to the plants, either for lack of availability or since someone help me out. What was the rail spill a couple of years back? Y'all remember that? What was it?
Eastbound.
That's right. That's right. They had that big spill, and regulations have been coming down ever since and making it a lot harder to move product and so on. And a lot of plants have been closing, which means higher cost, hard to get it. So they're looking at a dual factor. How can we use less chemicals? And also, how can we potentially make our own? And one of the recommendations they made was to basically install smart sensors for using less chemicals to do all that stuff.
The engineers never have to clean.
Engineers never have to clean it. That's right.
Anything longer and thicker sludge. I used to use screw press. And it sold as a self-cleaning.
Yeah.
It's just means it sprays the basket off. It doesn't actually clean.
I will say anyone who tells you that there's no maintenance or no PM, I haven't seen that type of instrument yet. I haven't seen that type of equipment yet. What we do is inherently dirty. You can be less, you can do certain things to make it, but at the end of the day, this is a dirty process. That's absolutely correct. Something where you're never going to eliminate the human factor in the operator, because at the end of the day, it's your license. Something where y'all have to take ownership of it, and it's a tool that can make things easier or smarter for y'all. And a lot of times folks will have this great next thing, this next sales thing, whatever. But it's really important at the end of the day, it's your license. It is. So you gotta take ownership over it, and especially as the operator. So it can be a tool to help make your life better, or it can be a problem, where you're having to conduct maintenance and it's really not worth it. So here's an example. Everything's in Spanish. So I apologize for that. I didn't have a chance to translate everything out, but this is basically some snapshots from their plant story. So this was a sludge blanket monitor they put in. They actually got a rain event. So they had just a tremendous amount of rain that hit the plant all at once, and they saw a big spike in their level. So this was the clarifier, which had run in the actual level, and that came in and it stirred it all up. It got into an upset condition. This was on a thickener, so it shot the level up. This is in terms of meters. I can't see here. So it ran all the way up to about 2 meters, 2.5. So what they were able to do is look at it and say, hey, you know what? We got a problem. They were able to react to it, settle it out a bit faster for that rain event. They got the first inrush, and then the rest coming in from, they had a huge I&I problem in the different lift stations and so on. And then pull that process data in to where it kind of goes back into normal parameters, right? So this was done. You can see over the time period, this is about a 6-hour span right here. So this entire event was 6 to 12 hours. That was kind of the nice thing about a continuous measurement, is it was able to get them live data so they could react to it a little bit faster rather than having to go out there and stick it in a big storm and have an issue with it. So they were able to actually prevent some washover because SCADA was set up on automatic alarms, kind of got everybody mobilized to go head out in the middle of the night with it. Another thing to think about is operator safety. Y'all heard this story. Water guy, he drowned this year. He was working overnight, only guy in the plant. He had his proper PPE on, had safety tied off, doing some maintenance on a tank, and slipped, fell, feet got busted, got tied up in the ladder, and they found him in the morning face down in the water. So it's something to think about with, just as we're doing our day to day, right? Just be smart, be safe, you know, check in with your buddies, all that good stuff. Another thing to think about is we kind of have in Florida, we have the opposite problem, y'all. I assume y'all have more cold weather issues. We don't really do cold weather. We do a lot of warm weather though. So we get tropical storms, hurricanes, etc. And some poor guys were having to go out and try to run the plants in the middle of pretty major hurricane events. And so for hurricanes, for those of you who've been there, you know, a lot of the issue, especially if you live on the coast, is not so much the wind. A lot of the damage actually comes from the storm surge. So that's the hurricane kicking up water and sending it in. It's getting constantly overfilling. It's like an overflowing bathtub. It's impossible to stop. There was one plant who, just one of the plants in our areas, they had something like 70 buildings underwater. And they were trying to continue to operate during that. Run generators, keep clarifiers, and just absolutely difficult. So another thing to think about is it's cold weather for y'all. You know, if it's getting cooler and the issues. So how do y'all react to a cold weather storm as far as measuring, maintaining blanket levels?
We look out the window. Looks good.
Looks cold.
That's right.
They ain't on fire. They ain't overflowing. We're happy. Yeah. Do you deal with icing on the clarifiers?
I mean, I don't know, the clarifiers we read to have air, so not really, you know, because it's still air on.
Mhm.
We use our clarifiers to hold the tank, so we're not supposed to, but it works good. So, we don't have a problem with that.
That's, I mean, book knowledge, field knowledge, right? It's the whole dichotomy
Yeah.
of what works, and you kind of know your plan and what you can get away with and everything else. A lot of stuff they say, oh, you absolutely have to have this. Unfortunately, that becomes more of a luxury than reality for a lot of us.
Yep.
Especially the smaller the plane you go to. We deal with some funny environmental hazards. I was out working at a stormwater station going into the Everglades, and it's hard to tell, but these right here are alligators up along the bank. So they're always like, oh, you know, make sure you don't go there's fences and stuff, but gators don't care about fences. They have 8-foot chain link fence, and a gator will go through it just like a truck. The operator was telling me, he's like, yeah, man, you have to be careful if you're going out in the middle of the night because there's panthers out here too. What do you mean? He's like, yeah, one jumped that fence. I'm like, brother, that's a 10-foot fence. He goes, yeah, I know. So he didn't even care. That's crazy. So all that to say, does upgrading to a continuous sensor make sense for you guys? Yeah, there's some process improvements, there's optimization improvements, there's some cost savings associated depending on how much you're running into dewatering and so on. But I think for, what I'll say was in my TikTok slide for you younger guys, the too long didn't read, right? Kind of the takeaway is, I think for smaller plants, the sludge judge is more than enough. I mean, from kind of our conversation around the room, seems like a lot of what you're doing is, you're just kind of doing your day to day. And I think the sludge judges are a great fit for you. Occasionally, if you're finding really inconsistent measurement, looking at that automatic, or excuse me, that manual optical type sensor, they tend to be $700, something like that. A little bit more fancy, but there's not a huge cost savings. You don't have to run wire and all that good stuff for it. For larger plants, I think there's more of a capability or requirement for continuous measurement because they're running on limited manpower. But I think for a lot of what you're looking at, the sludge judge makes a lot of sense, and that's why y'all like using it, right?
We had to abandon ultrasonic, choose sort of for clear water, the one occasion it's good.
So I got trickier for clear water application.
Clear water application, like the level of the tank or something, that's good. For measuring sludge, we never saw consistent results.
Was it reading the bottom of the tank too much or
Well,
reading too high?
as your sweep came by, your blanket would drop to almost nothing.
Mhm.
Or you'd have enough stuff on the top, scummings out to totally interfere with it, and it'd be all.
It'd be bouncing back and
Cabinets were like very, you wouldn't be able to see the blanket. So
Right.
it was just trying to do training to have consistent sludge measurements throughout all
Yep.
personnel. All, and I mean, sludge difference. Their box or whatever, so.
Yeah, exactly. It's cheap and it's all about just getting guys being consistent and doing it right. That's, I mean, that's something where it's a training opportunity, for the teams rather than trying to throw money at a problem that doesn't really exist. And that's absolutely a common problem with ultrasonic and sometimes even optical stuff is, especially if the tanks aren't consistent, if you're getting like huge inflows through a certain time of the day, you'll get those issues where you'll have either too much in flight and the sensor's tripping out on it. I think the technology has gotten better with it, but at the end of the day, it's finding the right tool to apply to the right need. I don't think that it, like I said on the other slide, it doesn't really make sense for y'all to try one size fits all. It's always going to be better. It's always going to work for you. It makes sense to try to sue it, especially if your manufacturer that you're looking at, if you're looking at any of these sets of equipment, highly encourage you to suggest, they put their money where their mouth is. Ask them to do a trial, something like that. Put something in situ, run it for a month, 2 months, something like that. Does it work? Does it not work? What's the data point? Something that we actually recommend as a manufacturer because we want it to be a good fit for y'all. We want it to be a good fit for us. What are some other, does anybody else have any experience with continuous measurement on the sludge blankets for clarifiers? Some stories?
Yeah, I've used them on a secondary clarifier, with good success. I was curious if you've seen them on primaries and thickeners. Show a slide with a thickener, what kind of consistency and problems do you have if it's super turbid throughout, and then you have that blanket at the bottom.
Thickeners actually tend to do pretty well. I don't have any of the data points from my particular devices, but because the blankets tend to be so dense, the turbidity doesn't really affect the ultrasonic as much. It's in the blanket. So the most common problem I see is folks just don't set them up right. They don't lock in the bottom measurement, be off by 6 inches or a foot, and it'll end up reading the bottom of the tank and showing a 0 value rather than the little bit of sludge. So installing it and calibrating it correctly is the biggest problem that I've seen. And I've seen them work pretty darn well on thickeners and
You
primaries.
do that with, just fill it with clear water to get that bottom measurement, or how do you calibrate that?
Sure. So I'm going to go way back to give you a visual on it. I like pictures. So for these sensor types, what you want to do is you're going to tell it, hey, the overall depth of the tank is, I'm just going to use round numbers because I'm not a very smart person. We'll say 15 foot, right? From here to here. And then you say, hey, this sensor is about a foot in. And then you want to be as tight as possible because a lot of these sensors are so capable, they can actually get through your flock, through your sludge, and then read the bottom of the tank. And it's just like, hey, I got a really strong return that's about 9 or so feet away. Well, let's lock onto that, and then it shows a 0 level. So it's something that you want to make sure that it's reading. And to your point, sir, as far as when the skimmer comes around and it kicks up that bottom, you want to make sure that you have 2 things. First is if it's the sensor's inserted into the water, you want something that's going to kick that sensor up, move it out of the way, and drop it back down without it losing the measurement. Something that dampens that measurement, and also something that's not going to be super reactive down here. Otherwise, your data is going to go, it's going to jump every time that skimmer comes around. And you're going to have that variance from the blanket not settled. But to your question, primaries work great. Thickeners work great. Secondaries probably the easiest because of the minimal amount of materials most of the time. Obviously, assuming the plant's healthy and running right, and we're not having a lot of overflow downstream. Tends to be the most successful application. They can also do sequencing batch reactors, SBRs. I don't see a ton of those out in the wild anymore, but that's something that this type of measurement works pretty well. Same for optical as well. I don't have any direct experience with the radiometric. It's a bit more not really my field. Awesome. Any questions? Sweet. Well, I appreciate y'all's time today. Thank y'all for
Don't leave yet, guys.
we got instructions.
And we actually have about 10 more minutes of class before you can get credit for your CEUs, so.
Oh, there we go.
So you guys need to ask questions
We're on
or
floor.
tell stories, do something. We gotta get the time in so you get your CEUs, all right? We gotta go to almost till 9 o'clock. I was running, I left my phone back there.
Oh, it's up.
10 minutes. Did everybody sign in? Everybody sign up? That's okay.
I got a
Yeah, go
question,
ahead.
Joel. So back to the calibration thing, what other kinds of steps are there if you're having readings that you are not expecting and you're wanting to calibrate? What other measurements could you take to verify and lock in that you're getting the right calibration?
Good question. So the first thing is just to make sure that as you're sticking it with the sludge judge, make sure you've got a good measurement. You kind of trust the guy who's been taking it. Maybe take 2, 3, take the average of those and say, okay, this is where we think the layer is. And then what you should do, the appropriate step should be, a lot of these times these instruments will have a measurement offset. I personally don't like adjusting the measurement offset. I think you should adjust the actual raw empty distance range here, because now whoever the INC tag or the vendor who's coming in to work on that, now they're having to juggle multiple things. So you would say, hey, we're seeing 3 foot of level. We should be seeing 2. Make that 1 foot adjustment on the actual C2. And most of these should have. See if we have a picture of one. Yeah, so most of these monitors should have something that gives you a visualization of how the unit actually sees it. So if you see them point, this right here is what the blanket should typically look like. It should be like a large shaded hump area. That's how most of the time they interpret these on the manufacturers. So if you imagine this is the sensor face, this is the bottom of the tank right here with this large vertical line. And you see how tall and strong that echo is. It can sometimes be a competing issue. So again, the most common issue I've seen in the past with them is them going down reading 0 because this echo is way too strong. And it's just a simple adjustment.
So would you, in real time, you could adjust by moving the sensor further away until it misses that signal on the bottom?
We tied a large bolt with the zip tie to one of those 100-foot tapes.
Mhm.
Lower it down,
Mhm.
you get exact right over the sensor. So you
Smart.
get exactly where the concrete is, right to the edge of the sensor. And that gives you your phase measurement where it's bottom.
That's a great way to do it, to have a measurement. Ideally, the product you're using, like this one here that we sell, it has the ability to do it all through the processing, through the programming. So you don't have to actually move the sensor and hunt with the sensor. You should be able to mount it, and as long as this sensor is completely submerged in water, all the processing should be done on the actual controls itself. So that should be started part of the commissioning to set it all up, rather than y'all having to go out there and move the sensor and reattach it and all that stuff.
So how often, I just got a lagoon, I don't got a reclamation or anything.
Sure.
How often do I gotta go out there with, check the bubble of this? Just check on the lagoon, how often?
As far as like just going and sticking it,
Yeah, well, I don't even have a stick.
you don't even have to stick.
Yeah. I mean, I just got straight lagoons, that's it. No-
I'm not sure on the what the book answer is for lagoon. I'll get back to you on that.
You got a little rowboat?
Yeah.
Yeah, I do.
So every day.
It depends on how,
I was just wondering, I don't check any of that shit,
right,
but also I don't know how often I need to. I'm learning, so.
sure. Yeah, I don't have a good answer for you on that one. I'll have to do some digging and get back to you. Get you.
I got lagoon treatment, and they just start, that's it. aerators.
Oh,
Gotcha.
Just kidding.
You're running pretty,
Yeah, I think there's like, you're gonna need to check it in.
I've been there 5 years, I've
I
never
know.
been down.
That's some of the lagoon probably. Be. Cause it's gonna change much less.
Same
Because
thing
the
with
floaters.
filters.
I understand. I understand. I'm learning on lagoons too.
So, I know if I have to check once a month, I have no problem, you know, conjuring up a stick and whatnot, but I
right.
just try to learn.
Yeah, no, it's a great question. And it's something where I'm not sure, so I'll have to do some digging to get back to you on it.
With the lagoons, it's honestly with checking lagoons, usually every 6 months, but it's also what you have to discharge. If you got a lot of, floatables going out and stuff like that, you have a lot of solids going out, obviously your blankets are coming up, so you're gonna have to check it. Then you're gonna have to check your permit and see what,
So
you're gonna have to de-water it when it gets so high and stuff. So a lot what the permit is, and it's what you're discharging. If you got a lot of floatables going out and stuff like that, or, flock, you probably should check it more often. And then when your blankets
Charging now.
3-4 feet, you have a problem,
Right. Yeah, good call.
YouTube.
There are some really great guys on YouTube who do it. There's one guy out of Washington. I think he's only got a primary, Florida. I forget the
In
guy's-
Washington?
Yeah, Washington.
Nah, that's not right. Easy.
There's a great guy. I think his name is like Vogel something in Florida. Where he's awesome. He has this like university class. He basically puts on for free. It's not on YouTube. It's like on Vimeo or something like that. But he helps operators pass the different cert levels or special. So it's A, B, C, D, etc. But yeah, there's tons of great resources out there on the web nowadays with just experienced operators sharing knowledge and that kind of stuff. It's been super helpful for me as a young guy still learning, and just talking to folks like yourself. Because everybody's got a different experience. Some of us are good at some things, and some of us are really good at other things, and so on. Together a lot. So that's why I always love getting together with World Water folks, because you'll see a bunch of different things. And you can cross-pollinate quite a bit.
Awesome, yeah.
You should see our alligators up here.
Yeah, they have fur on them and stuff. Anybody else had another question for Joel? Not, and we're looking good. We're doing good. So, and by the way, Idaho Rural Water Association will help you with sludge judging. Find out who your circuit rider is in that area where you're at. It's Curtis right back there. Talk to Curtis. Curtis will help you do sludge judging. He has all the information you need to be able to do that.
I was just more wondering how often.
Yeah, and he'll tell you how often.
I know I don't.
He's got all the answers for you.
That's it. You know a guy now.
Yeah.
Nice.
It must be.
Yeah, it's scary if Curtis knows all.
Yeah,
It's okay.